Okay, so today we're going to be looking at section 2.5, problem number 24. And in this case, we are being asked to graph the second derivative of the function. And we learned that the second derivative is the derivative of the first derivative. That's one way to think about it. It's the instantaneous rate of change of the function. But we can also think about it in terms of the shape of the function. And so we know that if our original function is concave up, then our second derivative, and let me actually just write it this way, then the second derivative is positive. So if we have this type of a shape, the second derivative is positive. If our shape of our original graph is concave down, then we know that the second derivative is negative. So if our original graph has this type of a shape to it, then we know that the second derivative is negative. And so what we need to do is go ahead and look at the inflection points of our original graph to see where we're concave up and where we're concave down and where those changes occur. So in right here, I would say, let me take this little line up here, and right here, I would say that from here to here, the shape of our graph looks like this. And so the second derivative there is going to be negative. Same thing is true over here. From there to there, the shape of our graph has this type of a shape to it. And so again, the second derivative is negative. And then between these two inflection points, the shape of our graph is like this, and so the second derivative is positive. Now, what's interesting to note is that if the second derivative starts off negative and then all of a sudden becomes positive, it must cross over that zero line in order for that to happen. So right at this value here, the second derivative is 0. Likewise, if the second derivative is positive and then all of a sudden becomes negative, once again, it must have crossed over that 0 line in order for that to happen. So that means that my second derivative is going to have zeros right here on the graph. It's going to be positive between those two values, and it's going to be negative on either side of those two values. And so the second derivative graph can look like what I just drew there.